Is the screen visible? Write down. Heisenberg, uncertainty, principle. Heisenberg, uncertainty principle. According to it, position and velocity of a subatomic particle subatomic particle cannot be cannot be given exact simultaneously. Simultaneously. Position and velocity, that is the momentum of a subatomic particle, cannot be given exactly simultaneously. There will always be there will always be some uncertainty in one of the two parameters. Uncertainty in position is given by delta x. Uncertainty in momentum is given by delta p. Delta p. Product of the two will always be lesser than or equal to h upon 4 pi. That is equals to a constant. If delta x increases, if delta x increases, it decreases. If delta x increases, delta p decreases. If delta x increases, delta p decreases. If delta x is zero, that means uncertainty in position is zero, that is position is known exactly, then delta P will be infinite. There is large error in velocity. Large error in velocity. Understood? Large error in velocity. And vice versa. And vice versa. Copy it fast. This is also Heisenberg uncertainty principle. For numerical purpose, we take delta x dot delta v equals to h upon 4 pi m, where m is the mass of particle. Where m is the mass of particle. Any doubt in this? Any doubt in this? These are very simple things. Can we say delta E dot delta T equals to h upon 4 pi is also Heisenberg uncertainty principle? Is this also Heisenberg uncertainty principle? Is this also Heisenberg uncertainty principle? How? We know kinetic energy is equals to energy in magnitude is equals to half mv square. So E is equals to half mv square multiplying both sides by m. It will become em into 2 is equals to p square. Listen to this, Pratyusha. Any doubt till here? Or we can say E is equals to P square upon 2M. If we differentiate with respect to P, if we differentiate with respect to P, then it will become dE by dP is equals to 2P by 2M. Any doubt in this differentiation? ये कट जाएगा dE by dP is equals to P by M. P is equals to M into V by M. M से M कट जाएगा तो dE by dP is equals to dx by dt, which is equals to velocity. If we cross multiply, then dp dot dx is equals to de dot dt. We know that this is equals to so the other one should also be the Heisenberg uncertainty principle. Understood? All of you understood this derivation? This question came in 2017, I think, or 16. So it is an important relation you should know. Understood? If the uncertainty in position and momentum are same, then change in velocity, that is the uncertainty in velocity, uncertainty in velocity will be equals to what? Will be equals to what? Will be equals to what? Delta x dot delta p is equals to h upon 4 pi m. if delta x is equals to delta p, then delta p into delta p will be delta p square is equals to h upon 4 pi m. Delta p will be equals to square root of h upon 4 pi m. So it will come out to be 1 upon 2 into root of h upon pi m. This will be the answer. Deepa, you didn't take 4 outside and m inside. Very good, Pratyusha. Done. All of you. Formulas are, sorry, questions are formula based, so that will not be asked in your exam because they are too much complicated. Okay. So this will be equals to m square delta v square. इसको थोड़ा change कर लो. There's something wrong in this. Delta v square will be equals to 1 upon m square into 1 upon, sorry, h upon 4 pi. The delta v will be square root of this. That will be 1 upon 2m h upon pi. ये हो जाए. Sorry. Okay, Asmita. Rebecca, understood now? So this much we have in this chapter. Numericals we are not doing, that will not be asked क्योंकि वो बहुत complicated होते हैं. They cannot be completed in 1 minute. Write down periodic classification. Write down periodic classification and elements. So all new students can join from here. Arrangement of different elements on the basis of some common property is done to study different elements called classification of elements. Classification of elements. We have to read only modern periodic table. We have to read only modern periodic table. Modern periodic table. Do all of us have modern periodic table as of now? Those who do not have, please take the pic of this. Those who do not have, please take the pic of this. Fast. Done. Modern periodic table is based on atomic number of elements. Modern periodic table is based on atomic number of elements. There are total 118 elements in it. Others are yet to discover. There are 7 periods. Horizontal rows in modern periodic table. And 18 groups, vertical columns in modern periodic table. Copy it fast. total number of gaseous element in modern periodic table. How many total number of gaseous elements are there? Total number of gaseous elements in modern periodic table. How many total number of gaseous elements are there in modern periodic table? 11. Shane, I'm talking about gases, not liquid. 18th group. Six elements. Nitrogen, oxygen, fluorine, chlorine, hydrogen, helium. Copy it fast. Maximum number of gaseous elements in which group period? In which group and period? Group 18. Group 18 and second period. You have the modern periodic table, you can check. All these are second period elements. Plus neon. Plus neon. 4 elements. Understood? Understood? Maximum number of liquid elements in modern periodic table. Liquid elements. Will be 6. cesium, francium, mercury, gallium, bromine, and copernicium. 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 Okay. 112. Yes, it is radioactive, but it is in liquid. It is a liquid element. No other classification was given. Okay, Rebecca. Deepika. Komal. Maximum number of elements in which group? Third group. 32 elements. This we have discussed also. This we have discussed also. Scandium, yttrium, lanthanum, actinium, 14,4F, 14,5F. Maximum number of elements in which period? Sixth or seventh period? Done. Sixth period or seventh period? 32 elements. 6s2, 4f14, 5d10, 6p6. Seventh period. 7s2, 5f14, 6d10, 7p6. Okay. Any doubt in this? Element having maximum melting point. Element having maximum melting point. Tungsten. Tungsten. Minimum boiling point. Minimum boiling point. Helium. Minimum melting point. Minimum melting point. Mercury. These are some of the basic information you should know. Okay. What do we mean by radioactive elements? What do we mean by radioactive elements? Those elements which disintegrate on their own, which disintegrates on their own. Those elements which disintegrates on their own are radioactive elements. What are transuranium elements? What are transuranium elements? Transuranium elements. Elements present after 92, that is uranium, are transuranium elements. All actinides are radioactive. All transuranium are radioactive. Among lanthanides, promethium is radioactive. All of it done? This was some of the information regarding modern periodic table. हमें जाना important जिस पे that is एक और लिख लेते हैं nomenclature of elements from atomic number greater than 100, greater than or equal to 100, greater than or equal to 100. Prediction, I already told you, it is very much important. Prediction is very much important. Electronic configuration also I told you, that is also very much important. ठीक है. 0 means nil. 1 means un. 2 is bi. 3 is tri. 4 is quad. 5 is pent. 6 is hex. 7 is sept. 8 is oct. 9 is n. That's it. Now, if we have to write down 100, what will be the name of this? Its name will be nil em. em लगाना पड़ेगा एंड में and no space. Okay. Pooja, Komal, Adric, nil by em. Nil pentium. By em. Septium. un, n, yum, un, by, nil, yum. Understood? This year question came on this. Which of the following is not there in modern periodic table? This year only the question came on this. Otherwise they do not ask you these things. But इस साल क्वेश्चन आया है. Just wait a second. All of it done? First one is wrong. First one channel. Okay. Adric, that was for the organic nomenclature. Here we just have to put EM at the last. Okay. That was for the organic nomenclature. It will be this only, un, nil, by, em. I'll just check it. I'll just check it and let you know. Okay. Because it was mainly for the organic nomenclature. Here, if we remove that bi, then we won't be getting by. I'll check it and let you know. Okay. Just hold it. Hold this. I'll check it and let you know. Okay, Asmita, that was for organic nomenclature mainly. Two vowels cannot be together. What are coinage metal? Coinage metal. We used to make coin before with them. They are coinage metal. Yes, Deepika, Asmita, very good. Okay, typical elements are called third period elements. Typical elements are third period elements. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. No, platinum was not included. Only we had copper, magnesium, copper, silver, and gold. प्रत्युषा कॉइनेज मेटल का मतलब इससे हम पहले कॉइन बनाते थे. It is not about reactivity and non-reactivity. मतलब it was about that, but they didn't make coins from that platinum. केवल कॉपर, सिल्वर और गोल्ड के कॉइन बनते थे, इसलिए उनको कॉइनेज मेटल बोलते हैं. Understood? Write down periodic properties. Periodic properties. Periodic properties. Those properties, those properties which shows a gradual increase or decrease along the group, along the group मतलब top to bottom or across the period. Left to right. Understood? Okay. What properties it will be? Atomic radii, ionization enthalpy, electron gain enthalpy, electron affinity, electronegativity, hydration energy. Copy it fast. Done. These all properties we have to read. Very important properties. They will come in block chemistry also. Block chemistry also. And chemical bonding also. Somewhat in organic chemistry also. Done, all of you? Now, for reading these properties, we should know all the elements. We should know all the elements. तो पहले elements लिखेंगे. First group element S block. It will be better if you keep this thing at the last page of your notebook. It will be better if you keep this thing at the last page of your notebook. नहीं तो बीच में कहीं खो जाएगा. इसको आप कॉपी के लास्ट पेज पे लिख लो. It will be required in other chapters also. बार बार देखना पड़ेगा इसको. Lithium, sodium, potassium, rubidium, cesium. 2s1, 3s1. ये है लीना की रब से फरियाद. Okay. लीना की रब से फरियाद. This is how we have to remember all these elements. It will be required in the questions. लीना की रब से फरियाद. ठीक है, all of us know what is फरियाद. Done. दूसरा second group S block. टू एस टू, 3s2. ये ऐसे हो जाएगा. वेरी गुड की माया. बेटा मांगे कार स्कूटर, बाप राजी. ठीक है. बेटा मांगे कार स्कूटर, बाप राजी. Copy it fast. Done. Thirteenth group. NH2 and minus 1D 10 and minus 1D 10 NH2 NP1. ठीक है, this will be your main electronic configuration. So this will be your 2s2 2p1 3s2 3p1 3d10 4s2 4p1 4d10 4s 5s2 5p1 5d10 6s2 6p1. Understood? You should know these elements where they are present with their the electronic configuration. ठीक है, यही हो जाएगा बैंगन आलू गाजर इंशाल्लाह. ठीक है, आपको और हिंदी में कुछ प्रॉब्लम है तो नेट पर सर्च करोगे तो आपको इंग्लिश के भी मिल जाएंगे. इंग्लिश में देखना है तो इंग्लिश में भी देख सकते हो. मेरे को इंग्लिश वाला नहीं पता है. बट ये निमोनिक्स है, अगर आप गूगल करोगे तो आपको इंग्लिश में भी मिल जाएंगे. बट यू शुड नो ऑल दीज एलिमेंट्स इन अ पर्टिकुलर ऑर्डर विद देयर इलेक्ट्रॉनिक कॉन्फ़िगरेशन. दैट इज मस्ट. इंग्लिश हिंदी मैटर नहीं करता है. ठीक है, दिस इज थैलियम, this is indium, this is gallium. Done. All of you. Done, all of you. ठीक है. Next 14th group. NH2 NP2. So 2s2 2p2 3s2 3p2 and so on. Okay, here there will be 3d10 also, 4d10 5d10. ये हो जाएगा चले सीताजी संत प्रभु. चले सीताजी सीताजी संग प्रभु. चले सीताजी संग प्रभु. चले सीता जी संग प्रभु. प्रभु is led, sung is 10. Understood? 15th group, this is bismuth, this is antimony, का नाम होता है स्टिल्बियम, स्टिल्बियम, दिस इज आर्सेनिक। ये आपको बताइए फास्फोरस और नाइट्रोजन। 2s2 2p3, 3s2 3p3, बाकी follow on, it will be NH2 NP3, understood? तुम कहाँ ध्यान दे रहे हो यार, ऐसे सब के बीच न्यूज़पेपर आज सब बिके। ओके, न्यूज़ पेपर आज सब बिके। Sixteen. All of you done this? बहुत टाइम जाता है यार इसमें। NH2 NP4, ये हो जाएगा 2s2 2p4 and so on, will be old style से PPO, PPO is cheating करना। Seventeenth group, we will write this also कि ये गैस है, ये गैस है, this is liquid and this is solid, NH2 NP5, 2s2 2p5 and so on। फूल कली बाहर आई आज, फूल कली बाहर आई आज। Okay, AT is aesthetic, aesthetic, radioactive। Okay, फिर 18 group I already told you, 18 group NH2 NP6 है ना, क्या था, हीना नीना और करीना का एक्सरे रंगीन। ठीक है, तो दिस हाउ You can remember all these elements. Understood all of you? ये सब आपको याद रखना है. Then only you will be able to solve the questions which are there in these periodic properties. इनका नाम है inert gas. Helium is 1s2. Remember this S block element. Halogens. Seventeenth group is halogens. 16th group is chalcogens. 15th group is pnictogens. Pnictogens. Done, all of you. चलते हैं प्रॉपर्टीज करते हैं. Fourteenth group is carbon family and 13th group is boron family. Pnictogens. This is carbon family and boron family. Understood? All of you. Okay, let's talk about atomic radii now. What is atomic radii? What is atomic radii? It is the distance between nucleus and the outermost electron of an atom. Nucleus and the outermost electron of an atom. इसके बीच का जो distance होगा that will be called atomic radii. Okay. Now atomic radii can be classified as covalent radii, metallic radii, van der Waals radii, and ionic radii. Ionic radii is slightly different, but we are keeping it here only. For ions. Okay. Copy it first. It is the half of the distance between two covalently bonded atoms. It is the half of the distance between two covalently bonded atoms. Covalent bond should be single, atom should be same. For example, hydrogen, chlorine. Take this, take another one, mark their centers. If this distance is d, then covalent radii of Cl will be d by 2. Understood? Understood? अगर ये डिस्टेंस d है तो कोवेलेंट रेडियस हो जाएगा हाफ. Now, as you have done both 11th and 12th class, tell me covalent radii can be calculated for. किसके लिए कोवेलेंट रेडियस निकाल सकते हैं? O2, O3, वाटर या फिर H2O2. O2 hidden. Why? O2 में तो डबल बॉन्ड होता है. This formula is only for single bonded atoms. ये तो गलत हो गया. Water में we do not have same atoms. वाटर में वी डू नॉट हैव सेम एटम्स, ये भी गलत हो गया। O3, O3, O3 में because of resonance there is a partial double bond character. O3 में there is a partial double bond character. We are looking for single bond. We are looking for single bond. ये भी गलत हो गया। H2O2. Yes. There is a single bond between two same atoms. And for this we can calculate the covalent radii. Understood? DD. Understood? Why we cannot calculate it between two different atoms? Why we cannot calculate it between two different atoms? Okay, so you have done both 11th and 12th class. That's what I'm asking. Otherwise, it's not possible for you. And radii also. No, why? Why we cannot calculate it between two different atoms? Because different atoms will have different electronegativity. Different atoms will have different electronegativity. So they can change the bond length. Different atoms will have different electronegativity, which can decrease or increase the bond length. Different atoms will have different electronegativity. Large difference in electronegativity decreases the distance. Decreases the distance. अपनी तरफ attract कर लेता है. More electronegative element attracts other atom as well, or you can say the shared pair of electron towards itself. So bond length decreases. Different atoms के अंदर bond length decrease हो जाती है. So we want same atoms to get the perfect answer. Understood? Understood? But in C2H4C double bond C. I didn't say it is not a covalent bond. I just said we cannot calculate the covalent radii for that. It will be lesser than the covalent radii between the two. As the bond order increases, covalent radii decreases. Deepika. I'm not saying it's not a covalent bond. Yes, it is a covalent bond, but covalent radii निकालने के लिए there should be a single bond. अगर bond order increase करता है तो bond length decrease करती है. Okay, अभी इतना करते हैं, बाकी we'll do in the next class.